Hello everyone, today we are going to learn how to compare the strength of the acids. So my name is Nidhi Narwal and we are going to understand it on the basis of stability of conjugate base. Okay, so let's begin. We want to compare the strength of the acids. I hope you can see the two different types of acids which are mentioned here. Carboxylic acid and then we have phenol. I want to compare their strength. What should I do? I should know certain rules for that. Okay, so let's learn about those rules, then we will come back to the question. So your strength depends upon the stability of conjugate base. Now, what is conjugate base? This is the species that you form after the removal of a proton. So, anytime they ask you to compare the strength of the acids, arrange them in increasing or decreasing order, compare their Ka value, compare their pK value, you have to follow the exact same thing. So, the strength of the acids will depend upon the stability of conjugate base. If they ask you the order of Ka, you have to follow just that. If they ask you their pKa value, that arrange them on the basis of their pK value, we are just going to reverse the order. Okay, but how do we compare the stability of this conjugate base? The proton that you have removed will give you a negatively charged species. So how do we stabilize something which is negatively charged? Maybe move that charge around. That will neutralize it or attach some electron withdrawing groups to it. Now, depending upon what type of compound is given to you, you will decide which one is more prominent. So, by resonance, we can stabilize a negatively charged species. Yes, if the charge is present at a single location, it is localized. It is always unstable. If you can delocalize it, if you can move that charge around, you are stabilizing your species. Let's talk about that carboxylic acid and phenol and let's find out which one is more acidic. Okay, so in the first case, this will be the conjugate base you will form after the removal of proton. And in this scenario, this will be the conjugate base. Now, in both of these cases, I hope you can understand that resonance is possible. So, the resonance will stabilize both species. Yes, it will. But which one will be stabilized to a greater extent? That was our question. So, in the first scenario, you will find equivalent resonating structures. Please see. What do we mean by equivalent resonating structures? You can observe it here. Do we see these two structures are exactly similar to each other? What are we drawing? Equivalent resonating structures. Are they getting any preference over our normal resonance? Yes. If you have equivalent resonating structures, they will stabilize your compound to a greater extent than the normal resonating structures that you will draw here. You can draw 5, but still your carboxylic acid is more acidic than phenol. The reason, equivalent resonating structures. Let's draw the 5 resonating structures for this phenoxide ion also and see for yourself. So you just have to move this charge around, nothing fancy. Now this will go here, negative charge will come at this position. Then this will move here. And finally, you will come back to the phenoxide ion once again, but see the orientation of double bonds. These two structures are not same. These two are resonating structures. So, as you can see in this scenario, there are 5 resonating structures which are possible. Greater number of resonating structures, more charge, delocalization, more stability. This is what we say. Yes, we do say that. But in this scenario, why we are not following that rule? Because we have equivalent resonating structures in this scenario. Although they are 2, they will be much more stable. So, equivalent resonance will always take precedence over your normal resonance. So, this one is much more stable your conjugate base, and that is why we always say our carboxylic acid is a much stronger acid than our phenol. Okay, so this is what we have done, everyone. If you want to see the order also, in which order you have to decide the strength of your acid, the stability of your conjugate base, please see this order. First, on the very first priority, you will have equivalent resonating structures. Then you have normal resonance or mesomeric effect. Since we are trying to stabilize a negatively charged species, hyperconjugation is not included here. And finally, at the very end, you will have inductive effect. So this is the priority order you will follow. Based on that, you can decide the stability of your conjugate base and in turn, the strength of your acid. Okay. So this was one simple question that we have solved. Based on this formula, you can apply it to other comparisons also. You have to follow the exact same order. Okay. So I hope you understood everything. If you want to learn more about us, you want to see more such amazing content, then you can follow SISYA class.